Overheating a water planet, warmed oceans will not be ignored. It's easy for us land dwellers to forget that we live on a water planet, more than 70% of it covered by a vast ocean. But we are entering an age, or more accurately, have created an age, when that fact will be impossible to ignore with global climate change. The seas are rising, yes, but they are also warming, slowly but steadily, and that warmth is now reaching levels that can drive profound changes here on land. Many of those changes have begun, many are on display this year, and some will have seismic consequences going forward. Almost as shocking as the scale of these changes are the Trump administration's efforts to dismantle the very scientific instruments that enable us to understand them. We'll get there. But first, a little immersion into our water planet to better understand what it means to overheat it and force the ocean to compensate. Earth, despite the name, is a water planet. A quick refresher on Earth's ocean. Where did it even come from, all this water? After Earth's molten formation 4.6 billion years ago, the planet gradually cooled below the boiling point of water, and fueled by steam released from volcanoes, it rained for thousands of years, filling the low-lying surface of the planet. An era of bombardment by icy asteroids provided a huge additional volume of water. And voila, a water planet was born, almost entirely covered by one massive ocean. Tectonic activity eventually produced large land masses, and over time, both plate movement and global temperature fluctuations have greatly changed the shape of the ocean and the land, our default perspective, e.g., tying more or less water up in ice. But with the exception of a couple of global ice ages, the liquid ocean has always dominated Earth's surface. We've almost always been a blue planet and always a water planet. Water manages heat and thus life on Earth. This water was the birthplace of life on Earth. Indeed, water is considered the birthplace of carbon-based life anywhere, which is why scientists search for it in other solar systems. It took at least 500 million years for the first life to form in the ocean, approximately 4.1 billion years ago. And once it did, life remained simple and aquatic for the vast majority of Earth's history. It took fungi, plants, and especially animals, big evolutionary leaps to venture out of the ocean, and much of it did not today. Nearly 80% of Earth's animal life, measured in biomass, lives in the oceans, first to the tidal zone, then the coasts, and even today, with terrestrial life spanning most dry land, the ocean continues to exert tremendous influence on that life. It does this through a range of mechanisms. Chief among them, our ocean plays the dominant role in managing the Earth's heat and making large regions of the planet habitable. A core way the ocean does this is by absorbing solar radiation at tropical latitudes and distributing that heat via vast ocean currents to cooler parts of the world. These currents then distribute water that is cooled at the poles back toward the equator. Without this mechanism, the heat that makes life possible, even in the otherwise frigid latitudes, would remain concentrated around an intolerably hot equator. In this sense, the oceans are a great regulator of the global climate, tamping down extremes and supporting Goldilocks-style, just right regional climates around the world. The oceans are also the primary source of moisture and precipitation, basically weather to land. As the sun heats ocean surface water, it evaporates, creating humid air that is transported by forces like winds and the Earth's rotation, delivering precipitation, the water that makes terrestrial life possible. So if the role of the ocean in managing Earth's temperature is fundamental to life on Earth, what happens when we overheat it? The ocean, an unfathomably huge heat buffer. The ocean is estimated to have absorbed 91% of the excess heat caused mainly by the burning of fossil fuels that has been trapped in the Earth's atmosphere. This heat storage is possible because of the ocean's specific heat capacity. That is, water takes a lot more energy to warm than land or air. Direct absorption of sunlight, the main way the ocean absorbs heat, depends on the level of albedo present, where darker surfaces, like the ocean surface, absorb more of the sun's energy than light surfaces, like polar ice caps, which reflect it back to space. But other mechanisms, like heat exchange with the atmosphere, warm the ocean too. Without that excess heat absorption and storage in recent decades, life on land would have been thrown into chaos at best by skyrocketing temperatures by now. According to one study, the heat taken up by the upper layer of the ocean between 1955 and 2010 was enough to warm the atmosphere by a jaw-dropping 36 degrees C. This massive climate-mediating role of the ocean puts our thus far unsuccessful human efforts to keep warming to 1.5 or 2 degrees C in sharp relief. That is, the ocean has spared us land dwellers from the true approximately 36 degrees C consequences of our fossil fuel burning actions. And we can't tackle 1.5 degrees. The buffer is getting thin. The vastness of the ocean means it requires tremendous inputs to respond. But the excess heat that carbon emissions have trapped since the start of the Industrial Revolution is one such tremendous input. Major recent research captures the scale in this way, according to one of a new study's 50 authors, John Abraham. The heat absorbed by the ocean in 2025 alone is like 12 Hiroshima bombs being detonated each second for every minute, hour, and day for the entire year. The absorption of that heat means that the average temperature of the oceans has been steadily rising, and now those temperatures are reaching levels that fuel impacts, including on land, that we will be unable to ignore. Overall, the ocean has broken average temperature records every year for the past 9 years. Temperatures have increased most at the surface, where sea surface temperatures have warmed roughly 0.8 degrees Celsius between 1901 and 2020, and recently broke new monthly high records for 13 consecutive months, starting in mid-2023. But deeper layers are warming too. The chart below shows ocean heat content at different depths, and while slow ocean circulation constrains the movement of heat to great depths, approximately 20% of total warming is occurring below 700 meters. So where are we today? The NOAA Sea Surface Temperature SST data in the chart below shows 2026 SSTs rising to rival the record-to-breaking levels of 2024. This is influenced by the formation of a super El Nino. Outlooks point toward new record-high ocean temperatures this year, potentially creating the new hottest year on record for Earth in 2027. Climate change is the clear driver here. Thanks to tools like Climate Central's Climate Shift Index, CSI, we can now see the role of climate change in daily sea surface temperatures, and thus in marine heat waves and other anomalies. According to the CSI, this week, both the notable heat in the Indian Ocean and that in the equatorial Pacific, where the El Nino is forming, are made substantially more likely due to climate change. Symptoms of the ocean's fever. These temperatures are now manifesting in impacts around the world and pointing toward accelerating change. In follow-up blogs, we will unpack these symptoms in some detail, but to name significant ones: warmer water hastens the melting of ocean-terminating ice sheets, that is, land-based ice connected to the ocean, contributing to sea level rise, creates a warming feedback loop by shrinking sea ice and increasing the ocean warming albedo affect, enhances ocean stratification. Where warmer surface and cooler deep waters fail to mix and redistribute heat, this in turn can drive hypoxic conditions, starving deeper waters of oxygen, can slow major ocean currents, thermohaline circulation, which are driven by changes in density, in turn driven by water temperature and salinity, and can supercharge storm systems, from tropical cyclones to nor'easters, causing stronger and more rapidly accelerating storms. Then there is the acute heat that manifests in marine heat waves, a condition that is now chronic and widespread in oceans around the world. In 2023, an estimated 96% of the ocean by area experienced a marine heat wave. The most significant heat waves, all recent, have disrupted marine food webs and caused major ecological harm, resulting in widespread, prolonged coral reef bleaching, large-scale wildlife deaths, and damaged commercial fisheries. Given the ocean's significant role in driving or influencing vastly consequential terrestrial climate patterns like the Asian monsoon, ocean overheating has implications for the human systems that are attuned to those patterns, from water supply to agriculture and food security, energy production, and more. We'll be tracking ocean temperatures, reporting on developments, and digging into these implications in subsequent blogs. An age of consequence for warming a water planet. The tremendous capacity of the ocean to store away heat meant that the consequences of warming our planet were slower to be made visible. It now means that an enormous amount of excess heat energy now exists in the ocean to be gradually released to other Earth systems in forms like direct heat to the atmosphere, as we see in El Nino years, melting of ice, and the supply of sea surface heat that fuels tropical cyclones, to name a few. It also means that releasing of that heat, slowing ocean warming, and eventually cooling the ocean cannot be accomplished on practical human timescales, but rather in hundreds to thousands of years. We have created an era of ocean heat consequences, and now we must figure out how to live in it, even as we work to correct it. Our need to understand our changing planet meets the Trump administration. An essential requirement for meeting the era of ocean heat is better understanding how our oceans and climate are changing, and for this we have global ocean and climate monitoring infrastructure. Here in the U.S., the Trump administration is attempting, through staff cuts, budget cuts, eliminating data and information, for example, data sets and websites taken down, and dismantling our monitoring infrastructure to make ocean, land, and atmospheric change harder to see. Most recently, the administration ordered the descoping of the National Science Foundation's Ocean Observing Infrastructure Project, a system of sensing and data gathering infrastructure distributed in North Atlantic and Pacific. Information is still sparse about this dismantling. The process is not transparent. What's clear is that at a time when ocean heat, the slowing of the Gulf Stream, and other major changes are sending shock waves through scientific and decision-making circles, we need greater understanding of what we're facing, not self-imposed blind spots. Sending taxpayer-funded ships on taxpayer-funded missions to essentially unplug functional taxpayer-funded ocean monitoring systems is baffling. Given the fossil fuel industry's influence on the Trump agenda, it could look like a massive attempted cover-up, except that the crime, warming the planet, is ongoing. And there's really no covering up the changing climate because we live here. The ocean has become easy for the wealthier people of the world to ignore, a place to extract resources and dump waste. But this titan is now rumbling into a new kind of activation, more central character than backdrop. It's hard to think of a more monumental failure than overheating an ocean planet and handing it off to younger generations. History won't look kindly on the leaders of this time who ignore the science and the obvious signals. May it reflect that they were forced by their people in time frames that made a difference to phase out fossil fuels and invest in a safe and just climate future for all on this rare water planet. We use cookies to improve your experience. By continuing, you accept our use of cookies.